Well, I think it's fairly clear that something's happening here. In fact, I've been involved in a lot of initiatives at Berkeley, and I've never seen one that has brought the whole campus together in quite such a remarkable way. And so thank you so much to the Gordon and Betty Moore and Alfred P. Sloan Foundations for prodding us to take part in this initiative. I can't help but start with one short analogy. Lewis Carroll invented many absurd things, and one of them was a map of the world on a scale of 1 to 1. Well, this of course is useless. You can't unfold it, and you can't see where you're going. Maps, to be useful, have to reduce the information into some usable form. With all of our data networks, sensors, museum collections, we're in danger of mapping the world on a 1-to-1 scale, and this initiative is about taking that information and making it useful in many, many contexts. It's really, really a wonderful thing to see the degree of engagement, and without wasting any more of your time, I'd like to introduce my boss, Chancellor Nick Dirks, to make the opening remarks.
Thank you. This is indeed a wonderful occasion, and I'm delighted to welcome you here to Berkeley to celebrate it. The launch of the Berkeley Institute for Data Science is, of course, part of a whole set of activities that we've been doing, but this is huge, and this is, it's bigger than big, perhaps as big as Lewis Carroll wanted it to be. I was at the White House last October, and I had the opportunity to meet with members of the President's Office of Science and Technology policy on a number of issues, and it was clear that big data was a key priority for the administration. And so it was wonderful to read the accounts of the launch of this in the White House when our colleague Professor Perlmutter was there, along with colleagues from NYU and University of Washington, as well, of course, as the Gordon and Betty Moore Foundation and the Sloan Foundation, which together, as you know, have pledged $37.8 million over 5 years to our 3 universities and to this project. This is just incredible. Making the most of data, and thanks to rapid technological change over the past decade, increasingly, every day it seems bigger and bigger data, is one, of course, of the great opportunities that will increasingly be central to our research and teaching mission across an increasing number of departments and programs at leading universities across the world. We know that these new approaches to data science will greatly help accelerate the pace of scientific discovery with far-reaching implications for basic and applied science, for business, public policy, society, and for areas that we perhaps don't even know yet. So I would like to thank the Gordon and Betty Moore Foundation and the Alfred P. Sloan Foundation for their leadership in this important area. Vicki Chandler is here today to represent both foundations, and she will say more about the approach that they pioneered in just a moment. Welcome. Vicki, are you here? Hi, Vicki. Saw you last at a football game.
Yeah.
I'm proud that UC Berkeley was selected from among 15 leading research universities to participate in this project, together, of course, with our partners from NYU and University of Washington. And I'd like to extend a welcome to 2 representatives from our partner universities, Bill Howe and Randy Levesque, who came down from Seattle to participate in this event today. Thank you also to Peter Norvig, Director of Research at Google and a UC Berkeley alum, and Tim OReilly, founder and CEO of OReilly Media, for joining us here today. Now, in my recent remarks, when I was inaugurated as the 10th Chancellor, I made specific reference to innovation in research as one of my core areas of focus, and thankfully, I can now claim that I'm moving ahead in this direction. Of course, I knew that this was coming soon, and I'm extremely grateful for it. Berkeley, of course, has been one of the most innovative centers for research in both the basic and applied sciences for many, many years. We established the first seismology station in the Western Hemisphere, We developed the flu vaccine, nuclear medicine, crystallized the virus for polio, founded the first biotech firm, assembled the world's largest telescope, found new planets, new elements, and determined that the universe is accelerating. So we've done a lot, but we've just begun. And as we go forward, we look forward indeed to the kind of partnerships this represents to play what we hope will be a unique role in the efforts to address today's technical and policy challenges that rely on data science. Again, I'm incredibly grateful for all that you've done to make this moment possible. We've been world leaders in a number of areas critical to this project in fundamental statistics, applied math, and computer science. We've also been leaders across many domain science fields, including astronomy and astrophysics, bioinformatics, genomics, seismology, economics, political science, and other social science fields, to name just a few. And we have a long tradition of multidisciplinary research that transcend traditional departments. But I think we've only just begun to realize the extent to which these initiatives in big data will bring departments, programs, schools, colleges, colleagues together in unprecedented ways, including, of course, all the issues that are being raised around privacy, around security, and, of course, around so many issues that I think we all know that we're being watched for on a regular basis. In 2012, UC Berkeley established several significant large-scale interdisciplinary efforts in the data science arena, including the Algorithms, Machines, and People Lab, the AMP Lab, launched with a $10 million NSF grant that has subsequently received very significant industry support. The Scalable Data Management Analysis and Visualization Institute at Berkeley Lab, supported by a grant from DOE of $25 million. And the Simons Institute for the Theory of Computing, led by Richard Karp, Alistair Sinclair, and a team of outstanding faculty. The Institute is supported by a $60 million grant, as you know, from the Simons Foundation, and just recently opened its doors in the newly renovated Calvin Hall. We also benefit, of course, from our unique and historic relationship with the Lawrence Berkeley National Laboratory. And these two institutions together are partners in a number of major research efforts related to data science. And I'd like to welcome, of course, Simon to represent LBNL today and thank him for their role in helping make this possible. In order to encourage further faculty collaboration and to bring together experts from computer science, applied math, and statistics with leading faculty in the biological, physical, and social sciences, our Vice Chancellor for Research, Graham Fleming, facilitated over the course of the past year a broad conversation across many different units on campus that have led to the establishment of this Berkeley Institute for Data Science. I'd like to thank in particular Nobel Laureate Saul Perlmutter and the team of 12 co-PIs on this grant who've come together from across the campus to launch this new exciting endeavor. The new institute will find a home in one of our historical spaces on campus, of course, in the Doe Library, and I want to thank Tom Leonard for his leadership in making available room 190 in Doe Library. It's right across from the Morrison Room, a mirror image of it. That was my first my first experience at Berkeley. It is a magnificent place to put this new effort, and thank you, Tom, and your colleagues in the libraries for that. Finally, I'd like to thank all of you for making this university the center in so many different ways for this kind of multidisciplinary effort. We have such a dynamic and engaged group of faculty and students who bring true passion and energy to this, as indeed to so many areas. Many of you will be exhibiting your data science projects at the fair that follows this event. And I want to thank Josh Bloom, professor in the Department of Astronomy, for organizing the fair, which represents a wonderful opportunity to showcase research, foster innovation, and enhance further interaction, not only across campus, but between campus and industry as well. It is now my great pleasure to introduce Vicki Chandler, the Chief Program Officer of the Moore Foundation's Science Program. Dr. Chandler is a geneticist who studied biochemistry for her undergraduate and doctoral degrees at UC Berkeley and UCSF, respectively. And she was among the students, I understand, that our most recent Nobel laureate, Randy Schekman, who collected his prize earlier this week, taught in the first class he offered at UC Berkeley. Dr. Chandler pursued postdoctoral research at Stanford University and was on the faculty at the universities of Oregon and Arizona, and is president-elect of the Genetics Society of America and a member of the National Academy of Sciences. Join me, please, in welcoming Vicki Chandler.
Well, it's a pleasure to be here, and I want to just add one thing to what Chancellor Dirks said. And not only was I in Randy's first class, I was actually the second person in his lab, because I was a brazen enough undergraduate to knock on this assistant professor's door and say, "Can I work with you?" And he was crazy enough to say yes. So it was awesome. He was an incredible mentor to me. So I'm thrilled for him this week. On behalf of my colleagues at the Moore and Sloan Foundations, I want to begin by echoing some of Chancellor Dirks' statements and really thank Saul, Graham, and the incredible team that have been assembled of 12 co-PIs. So everyone on that team and everyone who will continue to contribute going forward, you have all worked so hard to bring the Berkeley Institute of Data Science to reality that we're celebrating today. It has been so impressive to us to see what has been accomplished since February. It's just inspiring. And we at the foundations are really looking forward to working with you all to demonstrate how to successfully tackle the key challenges that all fields within the natural and social sciences are facing with the vastly increasing data. And so the team at Berkeley and the team at the partner universities at University of Washington and NYU, along with foundation staff who I want to acknowledge, Chris Minsel at the Moore Foundation and Josh Greenberg at the Sloan Foundation, they've co-created what I think is a bold set of experiments that have the goal of not only harnessing the full potential of the vastly increasing data-rich world that science is living in, but doing that by changing, modifying, improving the wonderful culture that's already here at Berkeley and making it even better. So this experiment, and you'll learn a little bit more about it from Saul in a few minutes, what you can learn in a 5-minute quick overview, will really test our hypothesis that advancing the people who are essential for the scientific data-driven discovery is what's going to change the culture that needs to be changed. And we believe when that culture starts to shift, it will revolutionize how science is practiced. Now, that's a big order. I'm sure Berkeley's up to it. I was a student. Actually, I was hanging out in Berkeley in the 60s, and I finally went to school in the 70s. And so I know Berkeley can catalyze revolution. And that's one of the reasons I'm very excited that Berkeley is a kingpin in this set of three. It's going to require a lot. It's going to require innovation within the methodological domains, such as computer science, applied math, statistics, and also innovation within the scientific domains. But most importantly, it will require cross-disciplinary students, postdocs, professional staff, faculty, all willing to work outside of their status quo and their comfort zone. And it will require administrators enabling, incentivizing them to do so. Berkeley's amazing faculty, trainees, and staff, its strengths across the methodological and scientific domains, its amazing culture, and its support from its key administrators speak to the high potential for making a difference. By working together, we can revolutionize how science is practiced. And when we revolutionize how science is practiced, that will stimulate discoveries beyond what any of us can comprehend today. We at the Foundations are really excited about our journey together with you. And I say, let the fun begin. Thank you.
So thank you, Vicki, and of course one of my first jobs as the first of, I hope, will be many faculty directors of the new Berkeley Institute for Data Science is to thank both the foundations, the Moore Foundation, Sloan Foundation, and the great program officers, both Chris and Menzel and Josh Greenberg, who really worked so hard with all of us to set this up. My second job is to welcome everybody, and I gather that we had an overflow of almost twice the capacity of this room at least. So I should also be welcoming whoever's out there listening on our overflow crowds, and it's really obviously this is all intended to make it possible for everybody who's here in the room and everybody out there in the corridors to be able to do so much more in the upcoming years. So it's really only because you guys are enthusiastic and interested that we're doing this. So that's the important part. I thought that I will describe just a little bit of why this is such an exciting opportunity, and then I'll leave it to my colleagues and my co-PIs to explain what we're going to do about it a little afterwards. I think that it's obvious that what drives a great research university is coming up with great questions to ask. And I think if you get a chance to be given some new questions that you haven't really focused on before, it can transform everything. So I'm going to describe to you, I think, what some new questions are that this allows us to focus on that you otherwise, I think, has often just been missed in our world. So let me begin by asking you to picture that you had the opportunity to invent the technology of the peer-reviewed journal for the first time. And conversely, imagine what it would be like to live in a world in which we had no peer-reviewed journals to allow us to build on top of what the previous generation is discovering. I think that's a little bit like our current position today with respect to a lot of the work that we do in order to achieve our science when it comes to data. That we're working in a world in which we are not yet progressive, and we have the possibility of making it something progressive, where despite the fact that we work in this constantly shifting sand of students and postdocs and scientists who are coming and going, and that's what we're trying to build on top of. And therefore, today we often lose whatever the previous generation of 2 years ago has just figured out. We have now the opportunity, I think, to make it possible to find and what's available and to contribute to the next generation of people in your own laboratory, people in your field, and people in other fields. And I think that that's one of the things that's just something that we could really invent. The equivalent of the peer-reviewed journal. There are questions which I think are perhaps easy to see in an academic world. We all know this problem of any interdisciplinary endeavor having the danger of falling between one department and another department, and therefore being very difficult to pursue in an academic environment. We see this in this particular area where these scientific approaches that you're trying to do often come along with a lot of expertise you need to have in the data sciences, and this really puts people in two different roles. This is something that Berkeley has solved before. We are actually very good at developing interdisciplinary answers to these kinds of challenges, and I think we can really contribute something here. We're educators, right? And to live in a world where so many of the problems that we would like our students to be able to tackle require just a little bit of extra understanding, a little bit of extra training of these skills of data science and computer programming is clearly an opportunity for us. We could make it, and I think we should make it, possible for every single one of our, let's say, undergraduates to easily join in a research group. A group like mine, we're constantly looking for anybody who could possibly do some computer programming and therefore jump into the science that we're working on, as opposed to we begin by teaching them how to work with data, and then we get to the science. This is saying that every one of our students should have the capacity to join any lab in the whole university, and I think, and similarly, the social science side of the world as well. This is obviously something that we should be good at. There are less obvious parts of the story, I think. One is that we're still often working in programming environments and programming languages where it's a bit of an obstacle to seeing the problem you want to see, to understanding what the data is telling you, to understanding the science. And we shouldn't see that as a God-given, form of how we're supposed to be working. I don't think God wrote in C. And so in principle, there should be other ways to organize our thinking and to work together in these kinds of languages. So I think that's clearly something that the computer science world cares about, and something that they're at this very university they're good at, and we should be able to take advantage of that. I hope that as we approach these problems, we'll start to recognize what are the interesting questions within the interstices between the science goal that you're trying to reach on the one hand, and the computer science excitement of some new idea on the other hand. There's a lot in between that we haven't learned how to focus on. And I think that there's a lot of intellectual excitement in those areas as well that we haven't yet mined. And so I see that as a really exciting new direction. And then finally, I'm describing this all as if we know what it is that we need to do, and in order to enable the scientists and the social scientists, and for that matter, the humanities in these respects. And I don't think that we should treat it as a done deal. We have techniques to find out what's hard to do and what we need to work on. And there's the whole area of ethnography has been a whole area that has been developed to try to recognize what it is that people are trying to accomplish and what it is that's holding them up. And we should take advantage of that. We should treat this as a research area of its own right, and we should do it right. We should get the answers. There may be surprises. It may not be what we think. It may not be just what we think, and there may be other elements as well. All right, if we do this right, I think that there's some really exciting potential that we can gain that may not be obvious as well. One is that there's most of the people I think who came to this room might be a little bit more data savvy than entire fields that could be using data, and I think that we could reduce barriers so that others can join in the fun and be working with data in their areas when it's appropriate. Of course, we should always remember, we should not just have people do problems for the sake of using data, but they should be problems for the sake of the excitement of the problem. But I think there's also a possible way to bring groups into the fields that are already using data who may not otherwise have had easy routes in. And so I'm personally a little bit interested in the question of whether we can make this another route for the underrepresented populations in these different fields. And we're very aware of it in physics, how hard it is to get a really nice, diverse crowd. And then in the end, doing this, I think, is exactly the kind of thing that you want a university to be able to do, because it's the fun of being able to work with other people, have excuses to hear about what's going on in research across the entire university, but have some concrete way of engaging with each other. This gives you a topic to discuss while you're getting a chance to hear about this amazing science that's going on in other parts of the university. And I'm hoping this will be a real source of many new interdisciplinary collaborations that otherwise would never have begun, just because they had to figure out what to do about some dumb little problem in data science, and maybe a fun problem in data science, and it turns into a new collaboration and a chance for a cosmologist to answer a problem in neuroscience, which I've always wanted to do. Okay, so let me finish then with just a last thought, which is there's the old quote about the definition of insanity is doing something over and over again, expecting to get a different result. And there is the danger of somebody looking at these lists of problems and saying, "But I've seen that problem before. We've been worrying about that problem for many years. What makes you think that we're going to solve it now?" And I'm actually really optimistic that this is a good moment, and the reason I think is twofold. One is that This particular world has been changing rapidly, of course, as all of you know. I think just the huge advances in open source software, already reminds us that there's different ways of thinking about this than we've done before. So that's one element. But the other is that for almost every one of the problems I've described, I can now go and I can see examples somewhere in our university or in other universities, including our partner universities, or out in industry, of really interesting ideas that would be the germs of solutions or actual solutions that if we could manage to make it work for a larger group, that would do the job. And I think, of course, that will lead us to feeling inspired about being creative and coming up with entirely new solutions. So this feels like the time to do this. It feels like the place to do it. This is the sort of color-coded map where you can see all the data sciences happening in these yellow-coded buildings all around the entire campus. We'll be right there in the middle of it all, and ideally bringing together all these great ideas and inventing new ones. So So that's the right transition to kick off why it is that we want to highlight just a few examples of this just to get a little bit of a feel of it. And so the next few talks are what we call lightning talks that will just present just a tiny fraction of a few of the things that are going on over this vast campus. And I'm going to introduce David Kohler, the chairman of the where was David? David, right there, right. The chairman of the Department of Electrical Engineering and Computer Sciences, I understand. And David also just received last week the Okawa Prize, if I'm pronouncing that correctly. And so it's always great to be able to bring somebody to the stage with a new prize in their hands.
Great to have a new question. So what language does God hack in? Yeah. So, we have a few candidates, I'd imagine. So this was an amazing year-long process and fascinating. We spent a year not writing proposals in this whole stage. And, all of these stages along the way, including the site visit stage when we had narrowed it down. It was only after that when we knew exactly who and how much that we began to write collective proposals. And yet, it was also incredibly circumscribed. And so I had the unenviable task of getting 12 faculty to present 12 talks in 60 minutes, each of which, could have been 5 hours of fascinating lecture. And it was amazing, so we wanted to replay a little bit of that. It turns out some of the faculty are still recovering, and so they sent delegates in there. So I'm going to welcome first one of those delegates, Solomon Tang, to come and lead us off. Come on up. I'm going to start my watch, and you'll see we also made it a little more exciting and only gave them 4 minutes. Sorry. Oh, that's right. We're going PDF here.
Great. Thank you for having me. I'm Solomon Shang. I'm at the Goldman School of Public Policy right across the street. And all of my work tries to understand what is the effect of the environment on human societies. So recently, Typhoon Haiyan sort of captured the world's attention. It was a major tragedy. And we've actually been studying the effect of these types of events around the world. It actually grabs people's attention in this type of natural disaster, a massive physical destruction of sort of infrastructure and loss of human life. But people are increasingly asking this question about what should we do after the storm? What is the toll going to be in sort of the long run? We've actually been studying this question for years, colleagues and I, and the way we do it is we've actually been rebuilding the history of different tropical cyclones, that's what these storms are called, around the world. So this is a 1970 super typhoon that struck the Philippines. And then what we do is we reconstruct many, many, many storms, the full history, hundreds of storms that have been hitting the Philippines over time. And then we link this data to very detailed information about what households have. So we go back and we have 2 decades of household-level surveys. And so what I'm showing you here is that actually in the year after a storm, on the x-axis is the wind speed of the storm a household was hit by the previous year. And we see that it's increasingly likely that if you're hit by a strong storm, you're missing the walls of your home. And we can actually, you should feel bad laughing. So you can actually repeat this exercise for all types of durable assets, and we see very similar patterns. Getting hit by a strong storm in the previous year reduces the probability that you have a refrigerator, a television, or a toilet. Interestingly, that you see no effect on cars, but if you think about it, cars are very mobile, and they're the one thing you can kind of get out of the way, given the short notice that you're about to get hit by a major disaster. Now, the major hidden tragedy of these events is that when a storm strikes, it actually causes a localized economic depression. So that at the same time that these households are trying to rebuild their lives, they actually have falling incomes. And so they actually have less resources at their disposal with which to do that. So how do they cope? Well, we've actually discovered by matching all this data together that they basically reduce expenditure on lots of types of things that we think are very important for the household's well-being. So, for example, what you see is that if you get hit by a strong storm, we're observing that the average household is reducing medical and education spending by roughly 30%. Okay? Now, given that the Philippines is hit by 14 storms per year, this has a major impact on the well-being of the society in the long run. And if we just look at things like food, for example, we see that in bad years, households are reducing their spending on nutritious foods like meat, eggs, and fruits by upwards of 30% on average. Okay? Now, this has real well-being impacts on the household. So one thing we can look at, for example, is infant mortality. And what we found is that after the storm strikes, so these are months going forward after a storm in month zero, we actually see infant mortality among young infant girls to go through the roof. Okay? So this gray line is showing abnormal infant mortality for the 3 years following a typhoon strike. And importantly, we think it's traveling through this economic mechanism, them losing their assets, reducing their spending, and reducing consumption of nutritious foods, because we see, for example, that baby girls that were not even conceived at the time that the typhoon hit end up having a substantially elevated risk of mortality in the following years. So what have we done? Well, we've actually matched this data to sort of the distribution of where people in the Philippines are. And on the left hand are the average economic costs and average death tolls over this 25-year period that are officially reported. And what we've inferred based on this sort of these hidden costs are on the right-hand side. And what we find are that basically the economic losses, and if you just count female infant mortality, these events tend to look roughly 15 times more costly than what you see in the newspaper. And so we're sort of trying to help people understand that what's really important is the rebuilding effort after the storm so that we can avoid those sorts of costs moving forward. Thank you.
Great. Thanks so much. Solomon had to go first because he's running across the bridge to the Geophysical Society to win all sorts of awards. Pretty unusual for a social scientist, but you can see why. Yeah. So, Rosemary, please join me. Rosemary Gillespie is next brave soul here. She's a professor in environmental science policy management and director of the Essig Museum of Entomology. And Charles is sitting back there comfortably watching. Thank you for doing this.
Okay, so what I'm going to talk about today is a new effort that we've started. We've initiated a huge eco-informatics project that focuses on rescuing and integrating biological and environmental data in the face of global change. What we're doing is using the past to inform the future. So what is the problem? The world is changing. It always has, it always will. But the current rate of change is unprecedented. It's super fast. We don't know how it's going to change as we go into the future. We've got to get a handle on understanding what's going to happen as we move into the future. How do we do this? Currently, what we do is look at organisms' distributions and see how they're limited. So you've got an organism there, for example, and we say that maybe it's limited by temperature, the most likely variables, and precipitation. So we say these are the physiological constraints for that organism. And so we can map where in ecological space it might be in the context of those climatic variables. Therefore, if those climatic variables change, we can predict where that organism is going to be. The thing is, this doesn't work that well. So, for example, this is just an example from the slider turtle, where you see the native range in green up in the US, the east side of the US. And what you see is the black indicates where that animal could live based on its physiological tolerances. But look where it invaded. The red dots indicated the invaded range, where this turtle has got to, that are totally unpredicted based on its physiological tolerances. The bottom line then is that based on current data, it's really hard to predict what organisms are going to do. There's a lot more going on than we can understand. So if we could just look back in time and build a trajectory from the past into the future, we'd have a much stronger standing to understand what's going to happen as we move ahead. This is where Berkeley has a supreme advantage. We have specimens, millions and millions of specimens, and each one of those specimens is like a little microcosm of historical environments. It carries genetic data, information on how those organisms were adapted to that environment, and little packages of that environment itself. So they have this wealth of information that we can tap into. Coupled with this, Berkeley has a tremendous history of development of informatics tools. We've developed tools for managing DNA data, for mapping biodiversity data, for tracking biodiversity data, and even tapping into the expertise of citizen scientists and using them to manage museum data. So we have this wealth of expertise, and what we're doing now is a hugely exciting effort. We're developing what's called the Berkeley Eco-Informatics Engine. What is this? What we're trying to do is bring together the huge amounts of very diverse data, bring them together in an open API development, integrate them, and serve them up in a way that they can be analyzed in the context of global change. So what we're doing then is looking at event data, all of the millions of museum specimens, each of which are specifically associated with a given space and a given time. We're using those specimens in the context of geospatial base layers. So these include land cover, climate, the lay of the land, the fire regimes, and the history of those landscapes as well. So we've got all of these base layers, all of these point data for specimens. And what we're trying to do then is integrate these pieces of data in a way that we can visualize and analyze them together. So this effort is a rich collaboration between domain scientists and informatics specialists. So we're enormously excited about the potential of the Berkeley Institute for Data Science.
That was great. So, Richard Allen is professor of Earth Planetary Science, director of the Berkeley Seismology Laboratory, and is incredibly good at this particular game.
All right, well, gosh, I better be careful. At least the slides came up immediately. That's a good start. So I'm in Earth and Planetary Science. I'm also director of the Berkeley Seismological Laboratory. And we, as in many of the fields that are represented here today, are experiencing this massive increase in the amount of data. And so I kind of want to illustrate that a little bit over the course of the next 4 minutes. I'm going to start by explaining what the Berkeley Seismolab is. We're based here, of course, at UC Berkeley, but we run geophysical networks that are across all of Northern California. This is our broadband seismic network, which includes some very specialized instrumentation, including on the ocean floor, in order to have sensors that are around all of the active faults. A very detailed, a very precise GPS network to see the actual deformation occurring on these faults, and then borehole instruments, where we put instruments very close to the faults to see very low amplitude signals, the very beginnings of earthquakes. And so we use this data, it all streams in real time into the Berkeley Seismolab here on campus, and we use it for a range of activities. These include, of course, earthquake hazard reduction. And just to illustrate that, another project funded by the Moore Foundation, you have to hear this. Oh, you still can't hear it. So this is our earthquake early warning system, which is now operational in a demonstration mode. This is an alert from an earthquake south of here, and you can see the energy radiating towards Berkeley, and of course we're getting warned before that energy actually arrives. And we can use this in order to take actions to prevent the effects of earthquakes. And I don't have enough time, though, of course, to explain to you what we could do. But that's earthquake hazards. What we also do is use all of the data for fundamental research, which of course is not in real time, to give you a sense of the range of things that we can do. On the left is an example from one of my colleagues who uses the broadband seismic network in order to monitor how energy from storms in the oceans propagates through the solid earth, essentially contributing to this background hum in the earth, and we can use that to track storm activity across the oceans. On the right-hand side is an example from Parkfield in Central California, where we have sensors down very close to the faults in order to understand the very beginnings of faults, earthquake tremor. That's another project actually that's supported to expand the networks by the Moore Foundation. But what is even more exciting is the potential of what we might be able to do in the future. That's the network we have today. I want to show you some data from this network, which was a network that was installed by the oil industry a couple of years ago now, Nodal Seismic. This is a network of sensors, 5,000 geophones they put out in Southern California, about 100-meter station spacing. So we measure our station spacing in tens of kilometers. This is now in hundreds of meters. And when you start to look at data from networks like this, it's just incredible. This is energy radiating across the network from a small magnitude earthquake in Southern California. You can see the black line is the Newport-Inglewood fault, one of the more dangerous faults in Southern California. And you can see the effects of that fault along with a whole bunch of other effects on the waveform propagation. I show this image to seismologists and they all start salivating. The things that you could start to do with this kind of data are just truly incredible. I mean, a whole new domain of seismology. So the opportunities are great for basic science to understand the structure, fault physics, earthquake processes, fluid flow in these basins, aquifer processes, and also for hazard. Of course, we can use this for earthquake alerts. We can use this to understand how sites, amplification effects occur, what happens in buildings. The question is, how do we do it? And so one possibility that we're very excited about right now is using the accelerometer in all the smartphones in your pockets. They, of course, they record motion. We have location. They obviously have communication. And, of course, there's a lot of them. 16 million in California. There's about 1,000 seismic stations in California. So we're talking about a 4 magnitude increase in order of magnitude increase. Yes, I got it. in the number of sensors. And, of course, we could do this globally. The challenge is how do you harness that? You do it by collecting the data. You need to be able to collect it in real time, process it in real time, archive it in order to make it available. Needless to say, there's a lot of big challenges. The heterogeneity of the sensor types, the platforms, and multiple software platforms, the volume of data. And so this is, of course, where BIDS comes in. We need a much wider spectrum of technical capabilities. We're actually very fortunate at the Berkeley Seismic Lab that we have a sizable technical group. But to take on a project like this is just beyond our means. But when we can, then there's obviously a huge amount of potential for what we can do. And so we're very excited about BIDS, both being able to take advantage of it and also, of course, to contribute to it over the course of the coming years. Thank you.
Tough act to follow. You can see why I put him last. Actually, so you can imagine that was 25% of the hour we spent with the foundations. It was great. So at this point, we'd like to shift gears a little bit and invite some of our partners to come and join us. Horst Simon first. Horst is deputy director up at the lab and personifies this mix of experiences throughout life in academic situations, in leading major efforts. He's run the computational program for many years, teaches courses in our department, so has lived across all the sides of this, and we're pleased to have him here. Thanks.
Thank you, David. Good morning. It's a great pleasure to be here and represent Lawrence Berkeley National Labs and kicking off the Berkeley Institute of Data Science. Being here, it's a good opportunity to reflect over many years of collaboration between Berkeley Lab and UC Berkeley. Of course, traditionally, we've been involved in physics, chemistry, material science, more recently than in biosciences. But I think over the last decade, we've seen a very substantial increase in our collaborations in computing sciences. And I'd like to use this opportunity again to thank UC Berkeley for the tremendous support we have received in about 2004, 2005, starting up the Computational Research and Theory building that is currently being constructed halfway up the hill. So you'll see it probably from here. This is a wonderful building, $140 million big building, but if you think about the future, we will consolidate all our computing and data activities in this building, sort of 5 minutes walking up the hill from Hearst Avenue and very close to Corey Hall and Soda Hall, so you can see an additional new focus on computational science happening. Again, as I said, it would not have happened without the strong support that came from UC Berkeley. Many of the other things that happened the last couple of years that were mentioned already, AMPLab, SDAF, the Simons Institute had some participation and some help that we provided to UC Berkeley. So we have reached, I think, today a very critical juncture. That juncture became obvious at the lab maybe 4 or 5 years ago. At that time, when I was still running computing sciences, we had the interesting observation that our big data center, supercomputing center, NERSC, suddenly attracted more data coming in than going out. Traditionally, you would think that researchers come to a supercomputing center and do some simulations and send the results off to their home institutions. But actually, the role reversed. The reason the role reversed because we've seen a fundamental change in the way our scientists at the lab and also nationwide dealt with data. That is, they used the ability of generating data and collecting data and needed a place to store it. So we have become much more data-centric. So I think we're at the threshold of a new age in science, for data-centric science, where the ability to analyze data, to use simulations, bring the simulated data together with experimental data, the way to go back and compare data that have been generated in different projects by different researchers to your own data, all these activities need tools and will fundamentally change the way we're conducting science. And it's fantastic to see some of the examples from colleagues at UC Berkeley that were shown here. The areas that we're interested in are in high-energy physics, nuclear physics, of course, traditional areas, cosmology, obviously, biosciences, genomic data coming from the Joint Genome Institute, light sources, where, again, the interaction with algorithms and reconstructing what we actually see in light sources are all computation and data intensive. More recently, some exciting new things have happened. One I would like to mention is the materials project, where we now, thanks to computation and data, are at a threshold of actually being able to construct materials on the computer for energy-intensive, energy-relevant applications such as batteries. All this is ushering in a tremendous opportunity for us in science. What I would like to conclude with is with a much more personal note, and this is reflecting again back over the time I returned back to Berkeley in 1996. And it turns out that by coincidence, maybe some of the first people I met or reconnected with were David Culler and Saul Perlmutter. But in 1996, it's intriguing to reflect on what we discussed. With David, I discussed, or at that time, how to connect networks of workstations together to build supercomputers. And Saul came by and we discussed how we could hire a postdoc to do jointly some simulations on those supercomputers to help him with his supernova cosmology project. And it's pretty amazing that a few years later, 17, 18 years later maybe, those two very different people actually work together on a singular project. So it tells me two things. One is, of course, that the common notion of looking at data and working with data has brought them together, but it also shows something else, and this is the incredible ability in Berkeley, people in Berkeley to work together, do things together, and fundamentally change what they're interested in. So I would have never thought, for example, that Saul would be leading a data institute. If somebody would have told me this in 96, I would have considered this as less likely than him winning the Nobel Prize. So with that, I wish David and Saul all the best for BITS, and I'm looking forward to many years of successful collaborations.
So we get to turn the mic over to some of our guests. Peter Norvig first. Peter Norvig is, of course, one of our alums, but also in his time as Google, has been also a tremendous friend of the campus. Many of you may have noticed this little thing called the MOOC revolution, this massive online classes. The first of those, Peter is the other half of that is often quiet in the background and so thoughtful about it. He's, of course, also, he received the College of Engineering Innovation Award's Lifetime Achievement Award. He's a AAAI Fellow, an ACM Fellow, American Academy Arts and Science member. So he, too, personifies this role of non-traditional paths with huge impact, and we're fortunate to have a few words. Thanks.
Okay. Thanks, David. Great to be here. So we heard earlier this morning, for a lot of people, when you think of Berkeley, you think of the 60s and protest, and these days it's the 99% and the Occupy and so on. And I think it's great that Berkeley is doing that because, the 99% are really in a lot of trouble these days. We've created this society, and a lot of it is our fault in the tech industry, where we really worsen this income inequality. Not because we're the evil 1%, but because this technology, first we made it marginal cost of productions of goods cheap because reproducing intellectual property is trivial. And secondly, we made communication around the globe cheap, so you could market very quickly to everybody, not just people within walking distance of your store. And that inevitably leads to concentration of wealth and a winner-take-all attitude. So what is the world going to be like for the rest of this 99%? Well, there was a recent study that said that roughly half of all jobs in America are subject to being automated away within the first half of this century. And you can object to the methodology, and I think they said it was 47%, which is way too precise. They really have no idea whether it's 47% or 30% or 60%. But these effects are definitely happening, that jobs are being automated away. Now, in the past, we dealt with this. We went from a society where 90-something% of the workers were farmers to one where 3% are farmers. But that happened over the course of generations. Now we're having jobs disappearing over the course of years. So how are people going to deal with that? And I think the main answer is everyone's going to have to become a data scientist. So the economist Tyler Cowen uses an analogy of a minor profession, which is less than 90% of the economy, which is chess players. And throughout all the centuries of history up to the last one, the best chess players were humans. Then computers can now beat all human chess players. But the best chess players of all are teams of humans and computers working together. And that team of a human helping guide the computer is better than even the best computers today. And I think we'll see more of that in all professions, that you'll have to be able to guide the work of computers, understand data, and work with that in order to get ahead and make your job be useful and to progress. And we've seen lots of cases of that where data can be used in professions that you wouldn't normally think of it. One of the things we did at Google was we've scanned all these books and we've made that data available. And that's useful for a lot of things. Linguists obviously use it to understand how language evolves, but it's used in other fields as well. So historians, for example. One historian had the question of how did the United States evolve in this dual vision of itself as a federation of individual states and also as a single republic? How do we view that, and how did that change over time? Now, you could go to original sources and read thousands of books and try to track that. Or from the data scientist point of view, you could go to this corpus of text and make a very simple query, which it says, give me a graph over time of the number of times that books use the phrase "the United States is" versus the phrase "the United States are." And you see a nice graph, and right after the Civil War, those two paths cross, and we begin to think of ourselves as a single unit rather than multiple ones. And so there, I just saved thousands of hours of reading with a single search. And I think all professions are going to go in this direction, where we're going to have to understand how data works in order to get ahead, to make sense of it, and to improve lives for all. So thank you. And also I want to say, I guess Tim's next? Tim is. Yeah. And I wanted to thank Tim because I officially became a data scientist when Forbes asked Tim to write an article about who the data scientists are, and he said I was one.
Well, that would bring us to Tim OReilly. So please, no, right, absolutely. There was only one reason for those of us in the open source world to have a bookshelf, and of course that's to keep those OReilly books, all of which have an animal on them. And so I don't know what language God hacks in, but certainly a God of the open source field, right? Please join us.
Thank you. So I'm a little abashed to be following Peter because, of course, so much of what I have thought about and talked about data over the last 10 years are in a lot of ways just simply a gloss on the work that Peter and his colleagues have done at Google, trying to explain to the rest of the world why what they were doing was so important and they better pay attention. And I remember back in 2004, 2005 at our Web 2.0 summit, one venture capitalist came up to me and said in a staged whisper, "Will you stop talking about this? We want to invest in it, and you're making it people too aware of it." And but the real notion that I kind of brought me to data was actually thinking about what would be the end game for open source software. And I was informed in thinking about that by what actually happened with the personal computer. IBM basically released the architecture. It was widely copied. The personal computer became a commodity, but it didn't lead to a world in which everything became, free. It led to a world in which something else became very valuable, i.e. software. Microsoft understood that, cornered a new monopoly. So when I was working on open source software, I started saying to the people in that community, you guys are focused on simply how you're going to replace the current world, but you're not looking at the lessons of history. And the lesson of history is that as the internet and Linux and other open source software commoditizes software, something else will become valuable. And I think it's data. And in particular, I think it's data that will, in the first pass, it's data that gets better the more people use it. The heart of my ideas about Web 2.0 were really that the sites that survived the dot-com bust were all good at harnessing collective intelligence, gathering data from their users, and literally getting better all the time because they were learning from data. And, of course, Google being one of the great examples of that. But then people would say, what's Web 3.0? And I'd say, well, it wasn't really a version number. It's the same web. But if there were one, it would be when those data-driven applications are fed by sensors rather than people typing on keyboards. And I think that has also turned out to be the case. And we're just at the beginning. And I think the thing that we don't fully understand, now first of all, I want to just say I'm talking about the commercial application of data. And I want to say I'm in awe of all the work that we've been talking about here about the scientific application of data because it's so amazing and powerful. But I also think that there are lessons from the consumer internet that will apply in science as well, and also in public policy, where I'm spending a lot of my time these days. But if you look at the way we have taken data in this world of the internet, first off, we're building, in many ways, a single global operating system in which the subsystems are data. Something like maps is a great example. any application now says, oh, wait, I'm going to be able to overlay data on where you are right now. But we also have other, effectively subsystems. We're building a who, what, where, and eventually how. But where we're getting to that really, I think, is super amazing is when you actually have sensors. This is the new Moto X phone. And I actually think this is probably going to be recognized as the next mobile inflection point after the iPhone. It's actually, in my opinion, more important than Google Glass as sort of a Google next-gen product because the phone is listening all the time. It's got this active display. I can talk to it without touching it. And that's that science fiction world where the sensors are starting to pay attention. The phone also, with this product Google Now, starts to tell us things that we might want to know. And it reminds me of a 2-year-old. It gets it wrong a lot of the time. It's sort of nattering at me with stuff. But every once in a while, my eyes pop open and it says, wow, it guessed what I would need to know. And you just think about how that's going to keep getting better and better and better as we have sensors, as we have these memories in the cloud, as we have enormous computational power able to put all this stuff together. And now you start taking that to the world of science and social science and policy. First of all, you have to get that if science and government and public policy aren't applying these same principles, they're going to seem really out of step with the world of what everybody expects. So for example, when you expect results in real time, getting economic figures quarterly will seem rather quaint. When you expect to have a system that's self-regulating, the notion of regulators who actually figure out a problem 7 or 8 years after it's been all over everybody's consciousness and then only then begin to try to do something about it will just seem curiously out of date. And then similarly, I think in science we clearly see the power that we can achieve when we put data together. But increasingly, I think one of the lessons for me in watching Google and others is that there's kind of an arc of data, if you like. And you can see it very clearly in maps. The first version of converting maps to electronic form was kind of static. It represented the paper map. Then it became more interactive. We got more layers on top of it. But by the time you get to the Google self-driving car, the map actually disappears into a service. And I think in a lot of ways that's also the future for a lot of science. We have this vision of, well, we're going to go noodling on the data and we're going to get results. But increasingly, we're going to be noodling on the data to write algorithms that will get the results. And that's where, again, this data science becomes so important because it's actually, the tool is, how do you tell the computer? This is kind of going back to Peter's comment about Tyler Cowen's point about chess. How you actually instruct the computer, how you work with that computer as a partner is going to be an increasingly important part of everybody's toolkit. But I think we'll actually see it first in science. The people who are actually science in this sort of commercial world of the internet. But we're going to see how those tools applied actually make some people much, much better at what they do, and that the people who haven't caught up with how we cooperate with this new world of data-rich, data-intelligent computing, they will be left behind. So the Berkeley Institute for Data Science is this huge step forward for a university to bring together the resources and the intelligence and the insight about how science is going to work in the future. Thank you.
Wonderful. So we're running just a few minutes behind, and what we'd like to do to kind of close us, move us towards lunch and this fabulous data science fair, it's just a word or two about how you can participate besides joining us today. And so I'm going to get a little help from Josh and Kimmin and Mike Franklin if you want to join me a little. One answer is we've worked very closely with the two foundations to try to build a structure that will continuously tie these three projects together. in the 3 different institutions. There's a structure of working groups. And so part of this is a message that there's really 2 agendas here. There's what we'll do locally, which we kind of view as this interweaving of, on the one hand, the methodological efforts in tools and environments, the mathematical efforts, the ethnographic efforts with areas of biological sciences, environmental life sciences, physical sciences, and hopefully environmental sciences joining. We also have this structure for how do we keep the exploration at these 3 institutions tied together on a daily basis. And that's looking at some of the working groups that provide bridges between those 2 worlds. So many of us in the proposal have been participating in these working groups. We view now that all 3 centers are getting launched as a chance to rebuild the participation in them, and we welcome broader participation in those working groups. We have a skeleton of a structure about how that particular weaving will happen. A central element very dear to Saul's heart is this notion of data science fellows, beginning to get a handle of influencing the career trajectories of faculty as well as scientists, staff, wide array of structures. You'll get a little bit more on that coming up in some of Kimmon's. And also really recognizing it's totally appropriate this is in the library, in that we're talking about curating software and data, and as well as the collections that we have. And we've already got started, Phil Stark, with Aaron Kulich leading a undergrad seminar this semester in reproducible science. And it's fascinating to see. We've had all of these boot camps all over the place. We'll create some structure around that. It's amazing how many hackathons. We had 350 students show up for the first hackathon this year in a room smaller than this. Yes, if you're wondering why you're getting sleepy and those sensors you talked about, parts per million, CO2, the answer would be probably about 1,200 in here right now. And, of course, the space to bring it all together, hopefully at a slightly larger role. So with this is also an assessment process. So a number of us have been playing together, usually at 8 a.m. meetings in Graham's office. We're now moving to a more regular schedule on some of that. And so we've organized ourselves as some initial committees to drive forward the initial efforts, one of which is building out the industrial consortium. And Mike Franklin, you want to say a word about that?
Yep. So thanks, David. So, my area of expertise is databases and data management. And, when I first came to Berkeley, I moved here from the East Coast. One of the first people I met was actually Richard Allen, who told me about the work that he was doing with earthquake early warning, and he had just recently moved here from the Midwest. And I said, oh, that's interesting. We both moved here to be at, ground zero of the activity in our fields. And, to me, that's one of the real opportunities that we have here at the Institute for Data Science is that, Berkeley has had a long tradition of data-oriented research, working very closely, informing and being informed by what's going on in all the industry in the Bay Area and beyond. And so BIDS is going to keep that tradition of engagement with industry. And to that end, we're looking to form consortia, or at least a consortium, with industries to, to go forward in terms of research, in terms of training, in terms of education. We're just at the early stages of this. We're trying to figure out what are the best ways to engage with the industrial community. And so really all I'd like to do at this point is just invite you to come talk to us. If you have ideas about how we can be collaborating, how we should be engaging, we'd love to hear those, and certainly you'll be hearing more from us in the future. Thanks.
And Kimmon, want to say a little more about how to participate?
Yes, thank you. It's a pleasure to see you all. We have a very large scope of what we want to achieve in the Berkeley Institute of Data Science. And we have a finite budget, so we've basically taking a potluck strategy. We want to bring everyone together so we can do some scientific matchmaking, so we can take people who are looking for problems from the methodological areas and take the problem domains and bring them together and figure out how to achieve all of our very large objectives within the scope of a very nice award, but it's definitely finite. So we have basically 4 different areas, and in the next week you're going to be seeing on our website and in your emails a call for participation and for proposals. This is the first stage, and we're going to be looking at all of the feedback we get from our community, and we'll come up then with some more concrete ways of applying for actual support for specific projects. So the first task is in our ethnography effort. So we want to understand the Berkeley landscape. So we want you to tell us what your needs are, to the extent that you really understand them, how we can help you be more productive in data science. And we're going to have training activities. These can run the gamut from boot camps and workshops. We want to help incubate new data science technologies and support existing data science technologies. Some of that can be through the Data Science Fellows Program, and some of that can be through providing technical expertise that's in-house already in terms of the computer science and statistics and applied math. And then finally, we want to help you harden and disseminate your data science software tools. There's a large scope of many other things that we can do, and we'll be asking for your input on that. Thank you.
And Josh, about a word about the fair?
A couple of words. Thanks everyone for coming to this event, but the next best thing is right outside. That's the Data Science Fair, and those of you who noted the E at the end, that's actually a little bit of a reverent nod to Tim O'Reilly and the Maker Fair. The idea that we could get an extravaganza of sort of an anything goes in the context of data science, and we've been completely blown away by all of you who have participated. We have over 80 contributions, with all sort of breadth and depth that we might expect at Berkeley, and just been very excited to see, sort of from astronomy to zoology, from undergraduates to faculty and staff. We're really running the gamut. And what I wanted to do here in starting the Data Science Fair, which I'll call the first annual one, hopefully there'll be more, is to really create a level set. So we see here that data science has actually been happening at Berkeley, and getting it all under one roof and getting all of you exposed to it, I think should be a very exciting time. So talk about what you've seen here. I hope you're going to learn a lot from your colleagues, and tweet about it at Cal Data Sci. And with that, I'll hand it back to David.
Thanks.
Panel afterwards.
Yes, and we're going to come back here at those that want to. Actually, why don't you do the panel?
Sure, right. So, I should have a couple more points of logistics. So there are actually 2 sessions in the fair. The first one will last about 45 minutes, an hour, and then we'll switch over to the second session. But importantly, after those end, back in this room, we will have a panel discussion about what we just saw and about the next steps with a prestigious group. So please do come back and join us.
And best in show at the panel too? We'll see about that. At this point, I get to turn it back over to Graham to wrap us up. And this has been an amazing process, and I can safely say that without Graham's guidance, it wouldn't have happened. And of course, like everything else in this, that wouldn't have happened without Kaya Sert, who's pulled all of this together.
Thank you, David. I can't not thank Kaya also. The amount of time and energy and commitment that she put in willing this to happen is really quite amazing. I think you've all seen that data science, if we do it right, will transform discovery and scholarship on our campus in everywhere from humanities through social sciences, science, and engineering. It is really an exciting beginning. You saw, Kaya, maybe you have to help me here. See, I'm helpless without her, but... you saw the distribution of data science across the campus, and it became clear as we were looking for a home, there was only one place to be, right in the middle. And I want to thank Tom Leonard, the university librarian, for his vision and willingness to see the role of data science in the future of the library and allow us interlopers to take over a gorgeous piece of his library. I'd like to show you a little bit of where this is going to be. No pointer on there. It's this space here, all of that, and it's quite fabulous. We've been working with an architect and the capital projects people. This is what we think it might look like inside. This whole ride, getting to when we occupy this space in March, is that right, Kaya? Yep. By hook or by crook? Yes. This has been a lot of fun to see how it comes about. I'm going to leave you with just some images of the process. It started out with actually in the bottom right, creation of this scroll there. Then you can't read the axes, but one of them goes from sublime to ridiculous, and one goes from low-hanging fruit to difficult, I think. And we made a list in this room. It's David Culler and Saul's writing on there on a Saturday morning of all the things we wanted to see happen. You see the team in the middle. We held several intermediate meetings. Here's one under the dinosaur in the museums. And seeing how all of these people from different disciplines came together. You've seen the list. And patiently learned how to talk to each other and how to collaborate. Was really, really quite inspiring. So now this is just the bit where I need to do the appropriate thanks. We've had help from a number of deans, Anno Saxenian, Mark Richards, and Steve Martin. Kathy Koshland and Abram Harden were really very instrumental in helping us find a home. Beth Dupuy, another associate university librarian, has been discussing with us how to make this space work for us. And in my office, a lot of people contributed to today, and I'm just going to list their names. Kim Carl, Jackie Jones, Susan Aberg, Amy Gonzalez, Sarah Hura, Melanie Myatt, Stacy Hanawa, and Kevin Zabo, and especially, and there she is driving the golf cart during the site visit, Cassie Darling. Are you in here, Cassie, or outside? I just want to take you back to Josh's data science fair with 80 participants, and there's food out there, I think. And so thank you again, and thank you again to the Moore and Sloan Foundations for enabling this exciting day.